Let us see a new system, induction system. This system is all about how the air gets into the engine, how is it routed, and how is it supplied to the fuel air control unit, and finally how it enters the intake port of the cylinders. So let us see what the induction system is all about. Induction system is the passage and controlling element for all the air required to be supplied to the engine. So induction system, it is a passage and controlling element for the air which is supplied to the engine. In the diagram you can see there is a duct here, you can see the duct here, then you have an air filter, this is an air scoop. So the air enters from this side, it enters the scoop through the filter. So induction system, it is the passage, this is your passage, complete passage, and controlling element, it controls the air which is going inside the intake system. The basic induction system of an aircraft engine includes three main sections. So a basic induction system has got three main sections. One is the air scoop and duct leading to the carburetor or injector. So this is your air scoop and the duct, this is first part which leads to the carburetor or the fuel injector. So this is your carburetor or the fuel injector, this is your fuel air control unit. So the first part is the air scoop and the duct leading to the carburetor or the injector. The second part is the carburetor or air control section of an injection system. Some aircrafts may have carburetors, some aircrafts may have fuel injectors. So the basic purpose of the carburetor and the fuel injector is to meter the fuel and in proportion to the air. So your air is coming from this inlet through the filter, it is ducted through this passage and enters the fuel air control unit, that is the carburetor. So the first part is the duct and the air scoop, and the second part is the carburetor or the fuel injector. The third part is the intake manifold and pipes. So you can see this is your third part, this is your intake manifold and the pipes. So your induction system has got three main parts. This is your first part, the air scoop and the inlet duct. Second part is your carburetor, and third part is the intake manifold and the pipes. Coming to air scoop and ducting, as we have seen in the last slide in the diagram, the first section is the air scoop and the ducting. So this is your air scoop and the duct. Let us see what is it all about. So in a non-supercharged, naturally aspirated engine, we will see what is a non-supercharged and naturally aspirated engine in our other slides. So in a normal engine, which we call it a naturally aspirated engine, the ducting system consists of the following. So the ducting system has got number one, an air scoop. Air scoop is the inlet, you can see it in the last diagram. This is your air scoop, so this is your air scoop, this is the inlet from where the air is going in. So it consists of an air scoop. Number two is air filter. Air filter, the basic purpose of the filter is to filter out air. Number three is the alternate air valve, and number four is the carburetor air heater or heater muff. So the air scoop and ducting, the first part of the induction system consists of an air scoop, a filter, an alternate air valve and carburetor air heater or muff. So here in this diagram you can see this is your first part, this is your air scoop, this is your filter, this is your duct, then you have carburetor heater, you can see here carburetor heater or the muff, and also alternate air. You can see here there is a valve here which is called it alternator air valve or the carburetor heat valve. We will see what is an alternator air valve or what is carburetor heat valve. An air scoop is an opening facing into the airstream. So we have seen it is an opening which is facing into the airstream. See in this diagram, this is open from this side, it is an opening which is facing the airstream. It receives ram air along with the propeller slipstream. So it will receive ram air along with the propeller slipstream. Since it is just in front of the propeller. So, it is receiving the ram air from the propeller. The air scoop is designed such that the effect of air velocity compresses the air a small amount, thus adding to the total weight of air received by the engine, resulting in increased power. Now, this air scoop is designed in such a way that the air which is coming inside through this scoop, the air is compressed, and which results in increasing the total weight of air. So, once the air is compressed, the weight of the air is increased, and finally the engine power is increased. So, we have seen how the air scoop is designed. The basic purpose of the air scoop is to direct the air. It provides an inlet to the air. The design is in such a way that the air is compressed and it increases the power, the engine power. The ducting seals and directs the intake air through various components of the induction system. It is made of either a flexible hose or is a solid mold. So, the duct is sealed and it directs the intake air through various components of the induction system. So, basically this duct is directing the air, and it is directing the air through the various components of the induction system. So, it needs to be completely sealed so that there is no air leakage. It is made of either a flexible hose or is a solid mold. So, in this picture you can see this picture. See, this is your flexible hose. This is a flexible hose, and the air is being directed from the scoop to the induction system through this flexible hose. So, this ducting can be either a flexible hose or it can also be a solid mold. In some of our engines, we will show you in how the induction system, this duct is, the induction system is. We will show you the duct, a flexible duct as well as a solid mold duct. Next is your air filters. There are various types of filters. You can see here in the pictures what is the basic purpose of a filter. The dirt, abrasive particles, sand, large foreign materials are prevented from entering into the engine by means of an induction air filter installed at or near the air scoop. So, filter is installed at the scoop or near the scoop, and it prevents foreign particles, large foreign materials, abrasive particles, sand, dirt from entering the engine system. So, this filter is filtering out the impurities from the air which is going inside the induction system. This dust and dirt can be a serious cause of trouble to an aircraft engine. So, in case if we provide unfiltered air to the engine, it can have dust and dirt in it, and which can be a cause of serious problem to the engine. What can be the problems? Because of dust and dirt, you see, it can upset the fuel metering elements, grind down the cylinder walls, piston rings, contaminate the oil, wear out bearings, gears, result in excessive oil consumption. So, this dust and dirt, it can upset the fuel metering elements. We will see in our fuel chapter, the fuel metering elements, they are very fine orifices, and this dust and dirt can harm these orifices, can obstruct these orifices. Then further, this dust and dirt can grind down the cylinder walls because they are all abrasives. So, and the cylinder walls, they are highly machined surfaces. So, this dust and dirt can grind down the walls. It can wear out the piston rings. It can contaminate the oil. So, you can imagine the lubricating oil inside the engine, if it is contaminated with dust and dirt, will harm all the moving parts in the engine. It can wear out the bearings, it can wear out the gears, and can finally result in excessive oil consumption. In extreme cases, it may also become a cause of oil starvation. So, dust and dirt can finally become a reason for oil starvation. That means the lubrication oil the lubricating system, it may get clogged, the orifices inside the system can clog, the oil gets contaminated, there may be leakages, and finally there may be oil starvation. There are basically three types of induction air filters: wetted type mesh filters, dry paper filters, and polyurethane foam filters. So basically three types of filters we will show you on the aircrafts: wetted type mesh filters, dry paper filters, and polyurethane foam filters. So different aircrafts have different types of filters, but the basic purpose of all the filters is the same: to filter out impurities, dust, dirt, abrasive particles from the air entering the induction system. The wetted mesh filter is a mat of metal filament dipped into oil and encased in a frame. So this wetted mesh filter, it is a mat of metal filament. So it is a metal filament which is dipped into oil and is encased in a frame. The oil film on the metal mesh filament traps and holds dust and scent particles. So it is basically the oil film on the metal mesh filament which will trap and hold the dust and scent particles. The dry paper type filter is made of pleated layer of paper filter elements through which the air passes. So this another type of filter, the dry paper type filter, it is made of pleated layer of paper filter elements. It is made of pleated layers of paper filter elements through which the air passes. The edges are sealed to prevent foreign material from entering the engine, and the edges of this filter element, they are sealed to prevent foreign material from entering the engine. Another type of filter is the foam type filter, which is made of polyurethane and a wetting agent. So we will show you the foam type filter. It is made of a polyurethane and a wetting agent. Alternate air valve. So we have seen in the first section, we have seen the induction system has got three main parts. In the first slide, this is your first section. We have read about the air scoop, we have read about the filter, and now we will see what is an alternate air valve. So alternate air valve, this is also part of the air scoop and the duct. So let us see what is an alternate air valve. Now in case if air filter or other parts of the induction system gets clogged, now there might be a possibility where your aircraft has been operating in very dusty conditions, very dry climate, dusty climate, so your filter might get clogged, or there is obstruction in other parts of the induction system. In that case, the alternate air valve allows the air to flow to the engine. So in case if your filter is clogged, your other parts of the induction system are obstructed, the alternate air valve will allow air to flow to the engine. This valve is either manually controlled from the cockpit or can be automatically operated. So this alternate valve, we will show you on the aircraft also what is an alternate air valve. It can be manually controlled from the cockpit. There is, in some aircraft, there is a control in the cockpit from where you can operate it, and it will provide an alternate path through the air, or it can also be automatically operated. You don't need to operate it from the cockpit, it can also be automatically operated. The alternate air source used may be unfiltered warm air or outside unfiltered air. So the alternate air source, it can be unfiltered warm air coming from the engine, or it can be outside air also, which is unfiltered. Since it is not coming through the filter, the air is obviously unfiltered, but it may be a warm air also coming from the engine, or it may be outside air which is not coming from the engine, but again both types of air, they are unfiltered since they are not coming through the filter. The alternate air valve source is also useful when the aircraft is flying through heavy rain. So in case if the aircraft is flying through heavy rain, in that case also your alternate air valve source may be useful. The protected air from the nacelle, which is free from rain, enables the engine to continue operation in a normal manner. Now since we have seen above that your alternate air, it can be your engine air also, which is a warm air coming from the engine. So that air which is coming through the alternate air valve is free of rain, and it enables the engine to continue operation in a normal manner. So alternate air valve source is also useful while the aircraft is flying through heavy rain. In some cases, the alternate air valve is labeled and serves as a carburetor heat valve, which allows warm air to enter the engine's induction system to prevent carburetor ice buildup. So since the air coming from the engine is warm, it also prevents carburetor ice buildup. It prevents ice to build up in the carburetor and provides warm air to the engine's induction system. Next is carburetor heat valve and heater muff. The purpose of the carburetor air heat is to prevent ice formation and to keep rain out of the carburetor. Just now in our last slide, we have seen that the carburetor air heat prevents ice buildup, prevents ice formation in the carburetor and keeps rain out of the carburetor. So here in this diagram you can see this is your outside air which is coming. This is this blue air, this is your cold air. This is coming from outside. Then you have your air filters here. Here in between you can see that this is your carburetor heat control. See this valve, this is your carburetor heat control. This carburetor heat valve, this is carburetor heat control, which is shown here in this diagram. The carburetor heat control in the cockpit operates the carburetor heat valve. So this carburetor heat control, this is there in the cockpit, this operates the heat valve. This carburetor heat control will operate the carburetor heat valve. The carburetor heat control in the cockpit, when turned on, closes the main air duct and opens the duct to the heater muff. Now when this carburetor heat control, this is turned on, this will close the main air duct. Now when this is turned on, this is your main air duct, this will close your main air duct. You can see here in the diagram, when this lever is turned on, it closes the main air duct, so it obstructs the passage to the cold air. So now the cold air is not going to the carburetor. This is your carburetor here. In normal case, air is coming through this inlet, going through this duct, and through this valve, carburetor heat valve, it goes to the carburetor. But in case when the carburetor heat control is operated from the cockpit, this valve will obstruct the path of the cold air. So the cold air is stopped here, it does not go to the carburetor, it is going overboard. You can see here, this is not going towards the carburetor. During normal operation, when the carburetor heat control in the cockpit is off, the spring loaded valve gate keeps the passage to the heater muff closed and the main air duct passage open. So now here is your heater muff, this is your exhaust heater muff. We will see what is a heater muff. From here you have warm air coming, this is your engine exhaust, gases coming over outside the exhaust. So this warm air is coming from this side, and when this carburetor heat control is turned on, it closes the passage to the main air duct, opens the passage of the warm air to the carburetor. So this warm air prevents ice formation in the carburetor. In normal case, when this carburetor heat control is off, this valve keeps the passage to the warm air off, obstructed, and the cold air passage is open and the cold air goes to the carburetor. That is the normal case. This valve is spring loaded. In the normal case, this keeps the passage of the cold air open, and when it is turned on, it closes the passage of the cold air and opens the passage of the warm air to the carburetor. A shroud, also referred to as a heater muff, opens at both the ends, is placed over a section of the exhaust pipe. So now this is your exhaust. So over the exhaust, over a section of the exhaust, there is a shroud placed over the section of the exhaust. So both ends you have the openings and air is flowing over the exhaust. So air flowing over the exhaust becomes warm, and that warm air is routed to the carburetor heat valve. This provides passage to the air from the engine compartment to flow into the space between the exhaust pipe and the wall of the shroud. Now, since as I have told that the shroud, it is open from both the sides, it provides passage to the air from the engine compartment to flow into the space between the exhaust pipe and the shroud. So now your air is flowing in the space which is between the exhaust pipe and the wall of the shroud. This warm air is routed from the heater muff to the main air duct. Since the air is flowing over the exhaust, it becomes warm and it is routed from the muff to the main air duct. Heated air results in loss of power as warm air is less dense than cool air. Now this heated air, it has its own disadvantages. The disadvantage is that heated air will result in loss of power since it is less dense than cool air. The carburetor air heat thus shall only be used to prevent ice formation and to keep rain out of the carburetor. A free flow of unheated air to the engine is desirable for maximum power. So for maximum power, you need unheated air to the engine, unobstructed air, free flow of air, cold air to the engine is desirable for maximum power. Now, coming to intake manifolds. So we have seen, coming back to the first slide, if you see the first slide, we have seen what is an air scoop, we have seen what is an air filter, we have seen what is a duct, we have read about an alternate valve, we have also read about carburetor heat, we have seen what is a carburetor heater muff, and now we will see what is an intake manifold. So as we have seen, the induction system has got three parts: the air scoop and the duct, the fuel air metering unit, carburetor, and third part is the intake manifold. So let us see what is an intake manifold. Induction system arrangements used are of the following types: updraft induction system and downdraft induction system. Now there are different types of induction system arrangements on different types of aircrafts depending on the components, the placement of the components. So induction system can be an updraft induction system and a downdraft induction system. We will show you on the aircrafts how do they look like, what is an updraft, what is a downdraft. In an updraft induction system, the induction air is delivered to each cylinder intake board by means of two runners and a balance tube with intake pipes for each cylinder. So here in this figure you can see, this is on the left side, this is one runner, and on the right side this is another runner, and this tube which is connecting the two runners, the left runner and the right runner, is the balance tube. So from the runners you can see there are intake pipes for each cylinders. From the runners you can see the runner, one in the left side, one in the right side, a balance tube and intake pipes from the runner to each cylinder. The balance tube reduces pressure imbalances between the two side induction runners. So the purpose of this balance tube is to reduce pressure imbalance between the two induction sides. With carbureted engines, it is important to maintain a constant and even pressure in the induction system so that each cylinder receives equal amount of fuel. So it is very important that a constant and even pressure is maintained in the induction system, and even pressure is provided to each cylinder intake port so that all the cylinders receive equal amounts of fuel. Now coming to another type of induction system, this is a downdraft induction system. So here you can see in the figure, this is your downdraft induction system. You can see the intake pipes, they are facing in the down direction. So that is why this is called downdraft. It provides optimum airflow to each cylinder intake port through a wide operational range. So this downdraft balanced induction system, it provides each cylinder intake port through different ranges to a wide range. In this figure you can see these are your intake pipes. Here you have, this is your manifold, induction manifold, this is your carburetor or the fuel air control unit, and these are your tubes or the manifold tubes. These are your intake manifold tubes, and this is your induction manifold. So these manifold tubes, they are going to each cylinder intake port. So the air is coming through this carburetor or the fuel air control unit, coming to the induction manifold, and from the induction manifold it is routed to different intake pipes. On fuel injected engines, the fuel injected from the fuel nozzles mixes with the air from the induction manifold at the intake port just before the intake port. So on engines which are installed with a fuel injector, the fuel is injected from the fuel nozzles. So engines which are provided with a fuel injector, they have the air coming out through this induction manifold. From this induction manifold, it is going through these tubes, induction tubes, to the inlet port of the cylinders. This air is provided through these pipes, the induction pipes, and the fuel is provided through a separate line, through a separate stainless steel line, and the fuel is provided to the intake port. It then enters the cylinder as a combustible mixture as the intake valve opens. So as the intake valve opens, the fuel and air mixture enters the cylinder as a combustible mixture. So we have seen an updraft induction system, we have seen a downdraft induction system. So both the types of systems we will see on different types of aircrafts. Now next is, what is the basic induction system, basic carburetor induction system? Air enters the induction system through an opening located in the propeller slipstream. As we have seen in our first slide also, the air is entering the system through an opening which is located in the propeller slipstream. Here in this diagram also you can see the air, this is cold air, this blue arrow is your cold air is coming through an opening in the induction system. The air is forced into the induction system, giving a ram effect to the incoming air flow. Now since this opening is in the slipstream of the propeller, so that propeller slipstream gives a ram effect to the air which is going inside the system. So since the air which is entering the induction system is getting a ram effect, it is also called a ram air intake. So this opening, this is also called a ram air intake because it is getting the ram effect from the propeller slipstream. The air passing through the air ducts, the air passes through the air ducts to the carburetor. Now this air has entered through this opening and it is routed through these ducts to the carburetor. Here you can see this is your carburetor. The carburetor meters the fuel in proportion to the air and mixes the air with the correct amount of fuel. So what is the purpose of the carburetor? The carburetor will meter the fuel in proportion to the air. The air, we will see in the fuel system how a carburetor works, how a fuel injector works. The purpose of the carburetor is to meter the fuel in proportion to the air, and it mixes with the air and provides a combustible mixture. The throttle control in the cockpit controls the throttle plate of the carburetor to regulate the flow of air, manifold pressure, and thus controlling the power output of the engine. The throttle control in the cockpit will control the throttle plate of the carburetor. So you have a control in the cockpit which is a throttle control. So when you move that control in the cockpit, that will move the throttle plate of the carburetor and will regulate the flow of air entering the system. So the flow of air entering the system, we also called it manifold pressure, and which finally controls the power output of the engine. So the more throttle you give, the more air is coming inside the system and more power output is being generated. So we have seen in this diagram the air coming inside through this opening. This is also called a ram air intake. The air is routed from here to the carburetor. Now it also has a valve, an alternate air valve or the carburetor heat valve. When this valve is moved, in case of filter being clogged or you need warm air inside the engine, then this valve is opened and you can get alternate air or warm air from this side and which goes inside the carburetor. We have seen in our earlier slides what is carburetor heat valve and how does it work. Now, what is induction system icing? We have been talking about carburetor heat which prevents icing in the system. So, what is induction system icing? Now, ice can form anywhere in the induction system. So, ice can form anywhere in the induction system while an aircraft is flying in clouds, fog, rain, snow or even clear air that has a high moisture content. So, when your aircraft is flying in conditions where you have clouds, fog, rain, snow or even clear air with high moisture content, ice can form in the induction system. Ice formation in the induction system is an operating hazard as it can stop the flow of fuel air charge or alter the fuel air ratio. Now, this ice formation, this is an operating hazard, certainly it is an operating hazard as it can stop the flow of fuel air charge or alter the fuel air ratio. So, you can see here in the diagram, this is your throttle, this is the carburetor and you can see ice being formed at various places. Now, when the ice is formed at various places, it can stop the flow of fuel air charge or it can also alter the fuel air ratio. The induction system icing, it can be classified as impact ice. This is your impact ice, you can see here this is your impact ice is formed here. Fuel evaporation ice, this is your fuel evaporation ice here. You can see here this is your fuel evaporation ice and throttle ice. This is your throttle here and ice is formed around the throttle. This is your throttle ice. A reduction in engine power with the throttle fixed is an indication of icing in the induction system. Now, if your throttle is in a constant position, you have not moved the throttle and still your power is reducing, your engine is reducing power, you can observe power being decreased, then that is an indication of icing in the induction system. Induction icing in an engine fitted with a fixed pitch propeller will reduce the engine RPM. Now, in aircrafts which are equipped with a fixed pitch propeller, we will see what is a fixed pitch, what is a constant speed propeller. In case if the aircraft is fitted with a fixed pitch propeller, then a reduction in engine RPM is an indication of induction icing. Now, in case if your engine is fitted with a constant speed propeller, decrease of manifold pressure will indicate that your power is dropping even though your RPM is constant. So, in case if you have a constant speed propeller, so decrease of manifold pressure will indicate that your induction system has icing even though your RPM remains constant, whereas in a fixed pitch propeller, reduction in engine RPM is an indication that your system is having induction icing. The formation of ice in an induction system is prevented by use of carburetor heat. We have seen in our earlier slides that induction system icing can be prevented by use of carburetor heat. The heat of the exhaust raises the temperature of the air between the heater muff and the exhaust before it flows to the carburetor. So, we have also seen how the heater muff works and how the warm air is provided to the carburetor which prevents induction system icing. So, this was about induction system icing. Now, coming to supercharging and turbocharging. So, what is supercharging? What is turbocharging? Why is it required? So, let us see. We all know that as we move up, as we move to higher altitudes, the pressure of the air reduces. So, density of air entering the induction system is also reduced. So, as we move up, the pressure reduces, the density reduces, which results in loss of power. So, a system is required for compressing or supercharging the fuel air mixture to regain the air pressure lost by the increase in altitude. So, whatever power we have lost by increase in altitude, we need to get that power. So, we need a system which will compress or supercharge the fuel air mixture so that your density is not reduced, your power is not lost. So, in order to regain the pressure lost by increase in altitude, we need to compress or supercharge the fuel air mixture. Induction systems for reciprocating engines can be broadly classified as supercharged and non-supercharged. We have seen what is supercharged. So, engines which can compress or supercharge the fuel air mixture to regain the pressure lost by increase in altitude is a supercharged engine. Non-supercharged engines which do not have this provision of compressing or supercharging the fuel air mixture. So, engines which do not have this provision to compress the fuel air mixture are non-supercharged or normally aspirated engine, since they are getting the normal air which is not compressed, and these engines when they fly up, as they go up, there will be a reduction in power. Whereas supercharged engines, they have the provision to compress or supercharge the fuel air mixture, so they will not face the problem of loss of power as they go up. So, two types of engines, supercharged engines and non-supercharged engines or normally aspirated engines. Supercharging and turbocharging allows an engine to develop maximum power when operating at high altitudes or to boost its power on takeoff. So, supercharging and turbocharging will allow engine to develop maximum power when operating at high altitudes or to boost its power on takeoff. So, there are two types. We will see in our other slides that the superchargers or the turbochargers, they can boost the engine pressure at higher altitudes, or they can also boost the pressure during takeoff. Supercharging systems are classified according to its location in the induction system of the airplane. So, depending on the location of the induction system, these supercharging systems are classified. One is internally driven supercharger, another is externally driven superchargers. Now, what are internally driven superchargers and what are externally driven superchargers? Internally driven superchargers compress the fuel air mixture after it leaves the carburetor. So, you can see in the diagram, this is your air intake, it is coming inside, it is flowing through the carburetor, and from the carburetor the fuel air mixture is coming. So, after it is coming out of the carburetor, it is going through the supercharger. So, internally driven superchargers, they compress the fuel air mixture after it leaves the carburetor. It is located between the carburetor and the cylinder intake ports. So, you can see here, this is your carburetor and this is your cylinder intake. So, this supercharger is located in between the carburetor and the cylinder intake port. And now, what is externally driven supercharger? Now, these externally driven superchargers, they are also called turbochargers. They compress the air before it is mixed with the metered fuel from the carburetor. Now, externally driven superchargers, they compress the air before it is mixed with the metered fuel from the carburetor. So, we have seen the difference between internally driven supercharger and an externally driven supercharger. Now, let us see what is an internally driven supercharger. So, if the supercharger is located between the carburetor and the cylinder intake port, then it is called an internal type supercharger. Now, we have seen in our previous slide that internal driven supercharger is located between the carburetor and the cylinder intake port. So, here in this diagram also you can see, this is your carburetor here, this is your carburetor and this is your cylinder intake port, and between the carburetor and the cylinder intake port, this supercharger is placed. So, since it is between the carburetor and the cylinder intake port, it will compress the fuel air mixture coming out of the carburetor, and So it is called an internally driven supercharger. These internally driven superchargers were used in old radial engines. So they are not being used now, but they were used in earlier radial engines. Internally driven superchargers are engine driven through a mechanical connection. So these internally driven superchargers, they are engine driven through a mechanical connection. Air enters the system through the ram air intake. Now air is entering through this system through the ram air intake. The air passes through the ducts to the carburetor. Now air is coming through this duct. Ram air is coming through this duct. It passes to the carburetor and is mixed with fuel. So in the carburetor, this air gets mixed with the fuel. The function of the carburetor is to meter the fuel in proportion to the air and mix the air with the correct amount of fuel. So we have seen in our previous slides also that the purpose of the carburetor, the function of the carburetor is to meter the fuel in proportion to the air and mix this air with the correct amount of fuel. So the carburetor will meter the fuel in proportion to the air provided to it and it will mix fuel with that air. The fuel air mixture leaving the carburetor is approximately at atmospheric pressure. Now the fuel air mixture which is coming out of the carburetor is approximately at atmospheric pressure. Now after it is coming out at atmospheric pressure, it is then compressed in the supercharger to a pressure greater than atmospheric and then enters the engine cylinders. Now the fuel air mixture which is coming out of the carburetor, since it is at atmospheric pressure, then it enters the supercharger. Inside the supercharger it gets compressed and the pressure is increased to more than the atmospheric pressure, and then after the pressure is increased with the increased pressure more than the atmospheric pressure, it enters the cylinder intake. Here you can see in this diagram, this is internally driven supercharger. You can see this is your intake air duct. We have the manifold pressure also, we have the manifold pressure gauge also here, we have the carburetor air temperature gauge also here. This is the carburetor, this is your supercharger, and this is your engine cylinder, this is your intake port. The manifold pressure gauge, you can see here, this is the manifold pressure gauge. The manifold pressure gauge is also provided, measures the pressure of the fuel air mixture before it enters the engine cylinders. So manifold pressure gauge, it is measuring the pressure of the fuel air mixture before it is entering the engine cylinder. It indicates the expected performance of the engine. So we get to know the pressure of the fuel air mixture before it is entering the engine cylinder. Since it is compressed to more than the atmospheric pressure, we want to know what is the pressure of the fuel air mixture which is going inside the engine cylinder. So the manifold pressure, it is an indication of the performance of the engine. The carburetor air temperature indicator measures the temperature of the fuel air mixture of the inlet air. Now the carburetor air temperature gauge, this gives us the temperature of the fuel air mixture which is going inside the carburetor. So we want to know the temperature of the fuel air mixture or the inlet air temperature. So for that purpose, this carburetor air temperature gauge is provided. Now as I have told that the internal type superchargers are now very rarely used. They were used in engines which were not expected to operate at very high altitudes. So as we know that this is Cessna 206 aircraft, let us look at the induction system. In this aircraft, you can see the opening here. This is an opening from which the air goes in. This is also called a ram air intake. It has a specially designed opening which adds to the power. As we have seen in our slides, the opening is designed in such a way that it adds to the ram effect. So the air enters from this scoop. So after the air has entered this inlet, it flows from this side. You can see here, this is an induction air filter. We have read about the different kinds of filters. So this is the filter which is used to filter out dust and other foreign particles from the air. The air is filtered through this and is routed through this duct. You can see here just aft of the filter there is a duct. The air is routed through this duct. It has, you see from this side, and there is a flexible duct which connects this duct to the fuel air metering unit. This is the fuel air metering unit. So the air has come from the inlet, it has gone through the filter, it is ducted through this duct and goes into the fuel air control unit. From the fuel air control unit, the air comes to the manifold. You can see this is the induction manifold, and as we have seen in our slides that there are two types of induction systems, the updraft induction system and the downdraft induction system. This is an example of a downdraft induction system. You can see the manifold and the intake lines. These lines, you can see 3 lines on this side, since this is a 6-cylinder engine, 3 on the right side and 3 on the left side. So these lines, they are connected to the intake port of the cylinder. So this line, you see all the lines connected to the intake ports of the cylinder. So the air, it has entered through this ram inlet, gone through the filter, through the duct into the fuel air control unit. Then it comes to the induction manifold, and from the induction manifold it is routed, it is ducted to the individual cylinders. So here you can see just at the bottom of the duct, just outside the induction air filter, this is the induction air filter, and just outside that there is an opening. This is called the alternate air opening. As we have seen in our slides, in case if the filter gets clogged, then due to the suction, due to the engine suction, this opening gets open and alternate air goes through this opening to the fuel air control unit. So we have seen the induction air filter, the duct and the alternate air entrance. Now the air, after coming from the induction manifold, it is coming through these induction lines to the inlet port of the cylinder. You can see here the air has cut. You can see that the air is coming through this line to the cylinder inlet, and this thin line, this thin stainless steel line, you can see this is also linked to the cylinder inlet port. Through this line the fuel is coming. So for the cylinder, the air is coming through this line and the fuel is coming through this thin stainless steel line, and both fuel and air are mixing at the inlet port of the cylinder. So we have already seen in our slides. Now this is the fuel line and this is your air line. Both fuel and air is mixing at the inlet port of the cylinder. So we have just now seen an example of a downdraft induction system on one of our aircraft, Cessna 206. We are now on another aircraft. This is our old aircraft, Cessna 182, which has got an updraft induction system. So I'll show you how the updraft induction system is like. This aircraft has got a carburetor, whereas our Cessna 206 aircraft, which you had just now seen, had a fuel injector. Both these aircrafts are naturally aspirated engines. They have naturally aspirated engines. They do not have turbochargers. They do not have superchargers. We have seen in our slide what is a natural aspirated engine and what is a turbocharged engine or a supercharged engine. So coming to the induction system again, this is the cowling. We have removed the cowling of the aircraft. You can see the cowling here. This is your induction air filter. This is your inlet. The cowling is like this. This air enters through this filter. You can see that the ram air, it hits this filter, it is filtered inside, and inside the cowling you can see that there is a special passage, special duct provided. So air through the filter enters through this duct, and through this duct it enters on this side. You can see the opening here, the scoop here. So the air is channelized through the filter and it goes through this duct. Now after entering this scoop, this is your carburetor. This is an old aircraft which has a carburetor. So this is the carburetor which is used to meter the fuel according to the air provided. So air, after entering this scoop, goes through the fuel air control unit, and from the fuel air control unit it is channelized to the various ports. You can see here, this is your induction ports. This is an example of the updraft induction system. You can see the inlet ports, they are moving up. See, this is one inlet, this is another inlet, and this is another inlet to the 3 cylinders. This aircraft is also having a 6-cylinder engine. This is a 6-cylinder engine, 3 cylinders on the right side, 3 cylinders on the left side. So you can see the ports here. This is moving up. This is in the upward direction. So that is why this is called a updraft induction system. You have seen it in case of a downdraft. These were moving in the downward direction. So this is your one bank on the right side. Similar bank you have it on the left side, and in between the two banks, we have seen in our slides, in between the two banks, you can see here, this is your balance tube to balance the air in between the two banks. So one bank on this side, another bank on this side, a balance tube, and updraft system. You can see all the ports, they are moving in the up direction. So that is why this is called an updraft induction system. So now the cowling has been removed. You can see the filter now. This is your wetted foam type filter. Air enters through this side, comes through this duct, is routed through this duct, and then, since this is a turbocharged engine, you can see here, this is your turbocharger here. The air enters to the turbocharger. So this is air coming through the filter, ducted through this side, through the turbocharger. You can see here, and then these are your fuel air metering unit. This is the carburetor here. One carburetor on right side, another carburetor on left side. This is a Rotex 914 engine. And again, you can see the induction system just after the fuel air metering unit. The air is coming out, and through these intake manifolds is coming to the cylinders. You can see again, this is your downdraft induction system, where the air is coming to the inlet port of the cylinders. So you can see the two ducts coming out, two on the right side and similarly two on the left side, since this is a 4-cylinder engine. So this is an example of a turbocharged engine. So in this you can see the alternate air path here. You see there is a control inside the cockpit through which this door can be opened, and you can have an alternate air passage through this opening. So far we have seen two aircrafts, one Cessna 206 and one Cessna 182. Both of them had naturally aspirated engines. This is another aircraft, Hansa 3, which has got a turbocharger. This is not naturally aspirated, this has a turbocharger, and I'll show you the inlet. This inlet you can see here, this is a specially designed scoop from where the air enters, and the air enters from this side, and just inside you can see a filter. This has a different kind of a filter we have seen in our slides, foam type filter, a wetted foam type filter. So the air enters through this inlet and then goes through the filter, where it is filtered out for all the impurities.